find the center and the radius of convergence of the power series indicated here. Now notice that since we're looking for radius of convergence, the ratio test is probably the best bet to go. So first, let's find a formula for our nth term. It's going to be 2n plus 1 quantity times 3x plus 4 quantity to the nth power divided by 5 to the nth. Next, we need the formula for the next term, which we get by replacing the n's by n plus 1's. So we'll have 2 times n plus 1 quantity times 3x plus 4 to the n plus 1. Remember, it's just the n's who get replaced, not the x's, over 5 to the n plus 1. Now we need to work out the ratio of consecutive terms. So we'll start off by taking the formula for an plus 1 and distribute through. So we're going to have 2n plus 3 times 3x plus 4 to the n plus 1 divided by 5 to the n plus 1. And now we'll divide by an, which just means multiply by its reciprocal. So we'll flip this fraction to have 5 to the nth over 2n plus 1 times 3x plus 4 to the nth power. And now let's look for cancellations. Hunt for exponents first. The 5 to the n goes into the 5 to the n plus 1 with a 5 left over. And similarly, the green 3x plus 4 is going to be left in the numerator. As for the remaining terms, these don't cancel at all. They're just going to form a rational function in the variable n, 2n plus 3 over 2n plus 1. And so this is going to be our ratio of consecutive terms. Now we need to take the limit as n goes to infinity of this ratio. So that's the limit as n tends to infinity, and I'm going to rearrange it here. We're going to have 3x plus 4 over 5 times 2n plus 3 over 2n plus 1. Why have I regrouped it this way? Well, because this expression here is a constant from n's point of view, and so it can be written in front. So we're going to have 3x plus 4 over 5, and then we'll take the limit as n goes to infinity of 2n plus 3 over 2n plus 1. Now this should be a pretty straightforward limit. Any of the tricks we've got in our arsenal will tell us that this limiting value is just 1. So we have 1 times the quote-unquote constant in front, 3x plus 4 over 5. So the ratio test says as long as the absolute value of this limit, 3x plus 4 divided by 5, is less than 1, we have convergence. Now remember that this inequality here just means that 3x plus 4 should be between 1 and minus 1. And so let's solve that. If we multiply through by a 5, we get minus 5 is less than 3x plus 4 is less than 5. If we were to add 4 to both sides, we're going to get negative 4, sorry. We're going to get minus 9 is less than 3x is less than 1. Now if we divide everything through by a 3, we get negative 3 is less than x is less than 1/3. And so these are the values for which the series converges. If we draw that on a number line, that means between negative 3 and positive 1/3 we've got convergence. Now the value dead center is going to be exactly negative 4/3. And that means we're going to have a length of 5/3 to the left and a length of 5/3 to the right for convergence. So if we put these facts together, we now know that the center of the series is centered at negative 4/3, and that the radius of convergence, the distance from the center to as far as we can get by convergence, is going to be exactly 5/3. And so we've been able to answer the question.